Hello everyone, welcome. So can you hear me?
Recording in progress.
Yes, sir.
Okay, so we will start. Can you see my screen?
Yes.
Okay.
Yes, we see you.
Okay.
Yes, I can see it's fine.
Okay. So hi and welcome to the second day's training session on beginners course on Google Earth Engine. So I am course conductor. So basically this is our second day course content and I will try to discuss all of this part one by one. So first of all, I will try to show you that how you can easily filtering and visualizing the satellite images using the Google Earth Engine platform. So mainly in this time, I will try to discuss about the Landsat and Sentinel, how we can easily filtering and visualizing the satellite images. And after this, how you can easily work with the satellite images and how you can easily export these images from the Google Earth Engine platform. Okay. Then how to make the time series chart. So actually you can also make the different types of time series chart using the Google Earth Engine data catalog. And then I also try to discuss about the normalized difference water index, how you can easily calculate it using the MODIS and Landsat data. Then how to export all of the map as a TIFF format. Okay, so I also try to discuss about this. Then how to export the shapefile. Okay, how we can easily export the shapefile from the Google Earth Engine platform and use this shapefile any geospatial software, just ArcMap or QGIS software. Okay. Then how you can easily filter the Sentinel-2 imagery, and after this how you can easily calculate the ANDWI. So first of all, today's session, second day session start. Before I also try to finish the previous day some part. I also try to complete this, then move to these classes. Okay. So previous class I also try to show you this part. Okay. So I hope you understand this code. So I also explain again for this code and finish all of the previous tasks. Then we will start our today's session. Okay. So first of all, I just simply import my MODIS dry vegetation indices 16-day global 250 meter this NDVI. I simply import this dataset. Then I simply from this dataset I simply select my specific band NDVI. Then I also use the you can see this is the size function. This size function determine how many images will be available here. Okay, here I can get only for the 505 images. Okay. And I also try to, you can see I also need the images between this time range. I only want calculated between the 5 years satellite imagery from 2015 to 2020. Okay, this time frame. Here I can get these images, and then I simply calculated the mean between those images which I get, and then I simply use here the visualization parameter, and then I simply show the result in here. Okay. So I hope, do you have any question in this time in this code? Any question or any doubt? Anything? Any question? Anyone?
No, sir.
Okay. So now you can see it will be calculated. It will be calculated the full, you can see between this time range, I calculated the mean NDVI or average NDVI for the whole world. Okay. But in this time, suppose in this time, I need only for the specific region. It can be your own shapefile, and I already show you that how you can easily import your shapefile in Google Earth Engine platform and work with this. Okay, so in this time I also try to show you that how you can easily clip with your shapefile for a specific boundary. Okay, suppose in this time I use here this dataset US-DOS. I use this dataset and I can get from this dataset for the all our country boundary shapefile. And I already discussed about this. So in this time I just randomly write this code. So I simply use a variable ROI and I store this in here. I filter my specific country boundary shapefile. So in this time you can see I simply use here the table, then simply use here the filter. e.filter, and I already discussed the more details about this code, and I simply use here the country, suppose NA, and I choose my specific country boundary, suppose Bangladesh. Okay, so here you can see I simply filter my own country boundary shapefile, and now you can see this result showing the whole world, but in this time I want to show this result for my specific country Bangladesh, and this country boundary shapefile will be stored under this variable ROI. Okay, this variable it will be stored. Okay, so now I just clip with my whole image with my this shapefile. Okay, so here you can see it, you can see this is the mean NDVI. Okay, this main NDVI I simply add here mean NDVI. So this mean NDVI represented the whole world for NDVI, but in this time I want to just clip with the mean NDVI with my whole collection. So for this I simply take a variable and give this variable name is the study area. You can use any variable name. I just put here the study area, and then I simply call my collection mean NDVI, and then I simply use here the clip function, and you can see what's the argument of this function. You can just press on your keyboard Control and space together. You can see this is argument is the geometry or feature. So in this time my geometry or feature is that you can see this is the ROI, because I stored this variable in my ROI shapefile. I stored this variable in the ROI. You can see this is the ROI. So just I copy this variable name and paste here. Okay, so in this time you can see my I want to show the study area result. So this is my final object. Okay, so I simply copy this final object and paste here. Okay, then click to the run. So in this time I want to get this result for my own country boundary shapefile. Okay, so you can see it will be appeared. Okay, so you can see this map will be appeared in here. Okay, and suppose I also use here the map center object for focusing this center of this shapefile. Sorry, map center object, and my object name is the ROI. Just put here the ROI, and I also put here the zoom level is 10. Okay, and then this on complete, it's not needed for this time. I simply remove and then click to the run. Okay, so you can get this result for country boundary of Bangladesh. Suppose you want to need the result for India, just change here India and then click to the run. So now I can get this result for India, for India country boundary shapefile. Okay, and we can also export this tip images from here, and I also discuss about this. Okay, so you can see this result will be appeared for the India country. Suppose you want to need the another country, Australia, just put here the Australia and then click to the run. Now I can get this result only for the country boundary shapefile for Australia. Here I can get the NDVI map between this time period. Okay, so here you can get this result. Okay, but it has a problem. You can see we already know about that NDVI or normalized difference precision index. This range between -1 to +1. This range value. Okay, but if you want to check the value, and I already talked about the inspector tab. Inspector tab is mainly work for the map querying result. Suppose in this time I want to get the map querying result in this point, simply click to here. You can get this value is not reprojected. You can see this value like this. Okay, 4233. Okay, so now in this time I want to reprojected this scale factor. Okay, and when I reprojected this scale factor, then I can get here the value range between -1 to +1. Okay, so now we want to reprojected it. Okay, suppose you can see here, this is my filter NDVI. Okay, and I want to check how many images will be available here. So I simply use a function, print function, then I simply call this variable name filter NDVI, and then I simply paste here and use here the size function. Okay, so now I want to get the how many images will be available between this time period. You can see, and console tab, you can see we can get here between this time period 138 images. Okay, from the modis NDVI, because I select here the NDVI band. Okay, but this image is not reprojected. Okay, so that's why I can get this result. You can see like this. Okay, so now I want to reprojected this 138 images so that I can get the reprojected scale value result, and this result range between -1 to +1. Okay, so now I am to reprojected it. So it's very easy. So you need to write a function, then you can easily do it. Okay, and we already know about that, how you can define the function using the JavaScript programming. Okay, so in this time I just write a function, and you can see this is our image information sheet, and in this time you can see here I use the NDVI band, and here already defined here the mean and max pixel value, and also they provide here the scale. Okay, they provide there the scale. So in this time I just multiply with this scale with my whole collection, then I can get the reprojected result. Okay, so this is my scale, so just I multiply with my scale with my whole collection, and my whole collection is that you can see 138 images. Okay, so this is my collection between this time period. Okay, I can get the 138 images. So now I want to make a function and multiply with this scale factor 0.001 with the whole collection 138. When I multiply with this, then it will be reprojected. Okay, so let's start. So first of all, I can take a variable and give this variable name is the scaled NDVI. You can use any variable name, it's totally depend on you. And then you can see here these 138 images stored under this variable filter NDVI. Okay, this variable it will be stored. So I simply copy this variable and paste here. After this I just make a function, it called map function. Okay, map is a function. This function connecting which function I created in this time, this function will be connecting with my whole collection. In this time my whole collection variable name is the filter NDVI. So now I just make a function. So we already know that how we can easily make this function. I simply use the keyword function. Okay, function, this is my keyword, and after this we use here the element between the parentheses. So I simply use here the parenthesis, and this parenthesis I give the element as a variable. I simply use the element name is the image or img. Okay, then I simply use here the curly bracket. Okay, and between this curly bracket I just put here my argument what I need. In this time my argument is that I just want to multiply with my scale factor 0.0001 with the whole collection, and whole collection here I already included filter NDVI. Okay, so in this time I use here the return function, return my image. You can see this is my element name image. I simply use here the image. This image multiply with my scale factor is that 0.0001. Okay, this is my scale factor, you can see 0.001. I just multiply with this scale factor. Okay, and you can see I create this function. This is my function I created. Okay, and this function add with my whole collection. My whole collection is the filter NDVI. Here included the total 138 images. Okay, and I just use here the element name image. This is the variable as a element name, and then I just use here the element multiply with my scale factor. Okay, then I also need to use a function. It's called the copy properties. Copy properties, and in this copy properties I simply use here my element name image. Then I define here my system time start and system time end. Here you can see, here I already defined a system. This is the system time start and system time end. Here I already defined this time. Okay, so just I simply tell them system time start, as well as also use here the system time end. Okay, that's it. Okay, so you can see here I just create this function. For this I simply call my whole collection filter NDVI, because this filter NDVI you can see I want to reprojected here all the 138 images, so I simply call the filter NDVI. Then I simply use the map function. I use the map function because I create this function, you can see, and I want to add this function with my whole collection. So in just so I simply use here the map function. Then I simply use here the function keyword, then use here the element name, and I return this element. It will be multiplied with this for this scale factor. Okay, then I define here the system time start and system time end. Okay, so now I want to check how many images I can get from after the reprojected this scale factor. Okay, so I simply use here the suppose here already I simply use the print, and then I simply copy this variable name and paste here, and then simply use here the size function. Okay, and then click to the run. So we can get the same result, 138 images after reprojected our scale factor. Okay, so you can see we can get the same result. But first of all, this filter NDVI, it included 138 images. It's not reprojected. Okay, scale value. And then when I just multiply with my scale factor, this scale factor just multiply with my whole collection, then it will be reprojected and I can get the same images. Okay, but in this time it reprojected, and from these images I can get my required result between -1 to +1, this range NDVI value. Okay, so now I just simply calculated the mean between these 138 images. I want to get the mean pixel value or average pixel value, so that's why I simply copy this variable name scale NDVI and then just paste here. Okay, and then everything is same, then click to the run. But in this time you can see we can get a totally white color map. Okay, you can see we can get the totally white color map because you can see here I calculated this scale factor so that this value, this range will be between -1 to +1. But here you can see in the visualization parameter, here I define here the mean pixel value 0 and max pixel value 8000. Okay, so that's why we can get the totally white map. So in this time I just change here this value. This value mean pixel value start with the -1 and up to max pixel value will be 1. Then click to the run. So now we can get here the reprojected scale factor, and if you want to check it, I can simply click to the inspector tab and click on the map. So now you can see this result will be 0.09. Okay, so now it will be reprojected, this NDVI value. And if you want, you can also export this map, and I also discuss later. And this time any question in here for the reprojected scale factor? Anyone, any question?
No, sir.
Okay. And I also provide you this code so that you can also practice, and face any problem just knock in our group. Okay, so now we will start our today's session. Okay, so first of all I will try to discuss about the filtering and visualizing the satellite images in Google Earth Engine platform. So first of all, you can see here, it is the one of the most fundamental part of Google Earth Engine is selecting and filtering image unit and display this image on the map. And Google has a a wide variety of public data set. Okay, we already discussed about all of the public data set. We can easily access the link. Okay, And in this time I also try to discuss about the filtering and visualizing the satellite images. Okay, actually filter, it depends on your some factor. Okay, it's depend on your region. Suppose I want to try to show you that Landsat 8 images. Suppose I want to need the Landsat images for a specific region, suppose Dhaka city or other region. So region is the one factor for filtering these images. Okay, so region, suppose I want to need the Landsat images for this area, Dhaka city. So this is the one factor for filtering. Then I want to need only for those images which image will not be more than 1% cloud cover. Okay, so this is the another factor for the image properties. Okay, you need only for those images which image will not more than 1% cloud cover. Okay, so this is the another factor. Okay, and suppose you want to and another factor is that suppose you want to filter this Landsat image only for your own time period. Suppose I want to need for those images which image will be captured at the year of 2017. Okay, so this is the another factor. So mainly when you filter your satellite image, it can be Landsat or Sentinel. It depends on your region. It depends the specific properties of this image. It can be cloud cover or other properties. Okay, and it also depends on your year, specific time period. Okay, so in this time I also try to give you example in my practical example in the code editor, so that you can easily understand everything one by one. So, and I also try to show you the next time when I go to the export part, then I also try to show you that how you can easily export this map as a TIFF format and work with the ArcMap or QGIS. Okay, so in this time, okay, so in this time I simply open a new code editor and I use here the Landsat 8. Okay, so I can simply search here this data set Landsat 8. Okay, okay, so I simply browse the data catalog. You can see browse the data catalog. I simply click to browse the data catalog. Okay, and after 10 minutes when this meeting will be in, then I will send you the Zoom link again, so please join. And then I simply click to the Landsat. So in this time I want to work with the Landsat, and this is our data catalog website for Earth Engine. So here you can see all of the collection about the Landsat 8. Suppose in this time I want to work with this dataset Landsat 8 top of atmospheric dataset. I simply click to here this dataset. Okay, so here you can see all of the information about this dataset. This dataset availability date, it will be start from the year of 2013 to present time. It will be okay. You can also see this dataset provider is the USGS and Google. You can also see the Earth Engine Snippet. Okay, so in this time I want to work with this dataset. So first of all I need to import this dataset in my code editor. Okay, so I just simply copy this collection snippet from here. Okay, so this is the another way for import the dataset in code editor. Copy here and paste in my code editor. So Earth Engine snippet is a this is the ID. Suppose you can see this is the Landsat, then Landsat 8, okay, then collection 2, then top of atmospheric. This is the specific ID for the this image, this dataset. Okay, so in this time I just simply copy this ID. It means that copy this ID and paste here. Okay, and when you work with the Python API, then you just copy this in here, just copy and paste in your Python API. And yesterday classes I already tried to show you this, so how you can create this. So in this time you can see Earth Engine snippet I simply copy. It means that this is the ID of this dataset, okay, of this collection, this dataset. You can see Lancet, then 8, then collection 2 tier, then top of atmospheric TOA. So every data set has a individual earth engine snippet. Okay, so I simply copy this snippet and paste here. Okay, and in this time I just make a variable. I simply use this variable name is that, and suppose L8. So I simply use the equal sign. It means that you can see this is my collection, full collection of Lancet 8 top of atmospheric dataset, full collection, and in this time this collection it is stored under this variable L8. So it means that now this dataset will be imported in my code editor, and now I work with this. Okay, so then suppose I want to check how many images will be available between this time period, year of 2013 to present time. How many images will be available for the whole world? I want to check it. Okay, so I simply use here the print function, and after this use here the variable name is the L8, and then I simply use here the size function. Okay, and then click to the run. So now it will be computing how many images will be available here. So we can get a long intro at the large collection of the data set. We can see here this number. So you can see we can get here the more than 1 million images will be available for the whole world for the collection Lancet 8. Okay, top of atmospheric data set. This collection is clearly too large to work with. So now we have to filter it somehow. And I already discussed about the factor, how you can filter the Lancet images for different types of factor. First factor is your region. Okay, suppose this image, you can see this image is available for the whole world, but in this time I not the whole world, I need only for my own area or on my shapefile. Suppose in this time I already show you that how you can easily import your shapefile in Google Earth Engine. So in this time I just simply work with this area. Suppose I need this for the Dhaka city, only for I need the satellite images for the area. Okay, I don't need the whole world, I need only for this specific boundary. Okay, for this boundary I need these satellite images. So I just import my area. So you can see it will be imported as default variable name is the table. I simply change it and give this name is the ROI. You can use any variable name, it's totally depend on you. So in this time you can see this is the full collection for the whole world. In this time I want to get only for this collection or only for those images which image will be available in my region of Dhaka city. Okay, so for this I simply use a variable. Suppose this variable name is the filter region. You can use any variable name. I simply use here the filter region, and then I simply call my full collection. You can see this total collection, it is stored under this variable L8. Okay, so I simply call this L8 and then use a function. It's called the filter bounds. Okay, so filter bounds is a function. It intersecting the whole collection with your region of interest. Okay, so in this time you can see this is the argument. So it will be intersection with your geometry. So in this time my geometry variable or shapefile variable name is the ROI. Just I put here the ROI. Okay, so in this time you can see here this is my full collection, and I use here the filter bounds function so that the full it will be intersecting with my ROI. The full collection will be intersection with my ROI or region of interest which I imported in this shapefile. Okay, so now I want to check how many images will be available in my Dhaka city, this shapefile. Okay, I want to check it. So I simply use here the print function and then just copy this variable name filter region and paste here. After this, simply use here the size function. So now I want to get the total image for my region of interest. So you can see I can get the 356 images will be available for my region of interest, Dhaka city area. Okay, and this image will be available, you can see, will be between this time period. Okay, the total time period, year of 2013 to present time. And this image has the lot of image properties. Suppose 1%, 2%, 5% cloud cover, all of the images will be available in here. Okay, but in this time I also need to filter for the image specific properties. Suppose from the 356 images, I want to need only for those images which image will not more than 1% cloud cover. Okay, I need only for those images. Okay, so for this I simply take a variable and give this variable name is the filter metadata. You can use any variable name. Okay, so here you can see these 356 images will be stored under this variable filter region. I just simply copy this filter region because from those 356 images I want to need only for those images which image will not be more than 1% cloud cover. Okay, so just I simply copy and paste here this filter region variable name, and then I use a function it called the filter metadata. Okay, so filter metadata is a function. You can see what is the argument. This is the 3 argument. First argument is the name, then operator, then value. Okay, so up less than 1 minute it will be finished. Then I also send you the Zoom link, so please join. Okay, so here you can see name is the image specific properties. Okay, so here you can see image properties. Here the different types of image properties will be available here. We can filter this image properties using this name. Okay, so in this time, suppose I want to need only for those images which image will not be more than 1% cloud cover. So this is my image properties. I want to work with this image properties. So in this time I just simply copy this image properties name and just paste here, and this is the string, so that I use here the single quote between two sides. Okay, then operator, I want to need less than 1% cloud cover. I just simply use here the less than 1%. I simply put here the 1.